Hello everyone, it's our great pleasure to be here at the AI4Legal Workshop 2022, presenting our work towards building a legal virtual assistant based on knowledge graphs. This is joint work between university and industries of Universitas Indonesia, Katapa, and GDB Labs. The presenters of the slides are me, Faris, and later on, Douglas. Let's get started. This talk consists of first, motivating scenario, second, architecture and implementation, followed by use cases, and then lessons learned, and we'll wrap up with conclusions and a demo of our system. This work is motivated by a use case from Katapa, which is an HRM platform, human resource management platform based on AI. One of the main goals of Ketapa is to provide knowledge services related to laws and regulations about labor or employment. Such services, in order to hit the spot, would need to have the capabilities of capturing the semantics of legal knowledge and supporting the law component retrieval in a human-friendly manner. Virtual assistants or VAs come in many forms, including chatbot. Chatbots are generally considered human-friendly, and in various domains, VAs have proven to provide helpful information. Here, we focus on the legal domain. On the other hand, knowledge graphs or KGs allow for rich representation of knowledge, giving the semantics on top of data. KGs are gaining more and more use in the legal domain. From the EU, there are EU-Lex and Links. And from Indonesia, there is Lex2 KG. We explore how the benefits of the two words can be combined to make a KG-based legal VA. Now, I'm handing over the presentation to Douglas.
Right. Thank you, Faris. So, I will explain briefly on how we construct the framework of our legal virtual assistant. We break down the architecture into two major components, which will be explained later on. So the first one is Lex to KG, and then the second one is the knowledge graph virtual assistant system. So our motivation to use Lex to KG is based on the fact that our country, Indonesia, and many other countries digitally disseminate their laws as text documents. So with this in mind, we use Lex to KG to convert legal PDF documents into knowledge graph. The ontology itself consists of legal-related classes such as legislation, chapter, and article, and then also properties such as cites, part of, and amends. The Lex to KG has previously been published as a preceding article, and the ontology is already made publicly accessible. Secondly, our legal virtual assistant consumes the legal knowledge graph to provide legal knowledge services. It receives user questions and answers accordingly. We propose a hybrid approach in the answer fulfillment process, which involves knowledge graph querying and text-based retrieval. When the system receives the question, the router will first determine which intent that corresponds to the question. Once the intent has been predicted, it will be routed to either text retrieval or knowledge graph query. We use BM25 based ranking system to retrieve the relevant law components to the question. And lastly, in KG query, the system performs query to retrieve law components and enrich answers with context and metadata. Next, we identify 4 use cases that the legal knowledge graph virtual assistant will be of use. The first one is question answering over legal structures. Skimming over pages of text documents would take a chunk amount of time, so our legal virtual assistant allows retrieving articles and subsections directly This is supported by the ontology used, which accounts for legal structures as mentioned previously in Lex2KG. And then, the second use case is question answering on sanctions. This use case integrates multiple components, in which the two components are the violated law and the corresponding sanction. The retrieval module enables the system to get the relevant violated law, and then the KG enables the system to find the sanction for that violation. So for example, when the user looks for the sanctions for the employment of underage workers, the retrieval module will retrieve Article 68, which prohibits such thing, and then the KG will retrieve Article 185 that says the sanctions for violating Article 68. And then the third use case is on how the legal KG can enrich answers to the user questions. Using the Lex2KG ontology, we are able to use three types of enrichments. So the first one is law metadata. So in law components, such as articles and subsections, we can get the chapter title so that the user understands the larger context of the article. And then we also have citations, because oftentimes articles cite another articles. For example, this article on Article 77 subsection 2, it refers to another article which is Article 77 subsection 1, and then it is also being cited by another subsections. And then finally, we can also get the metadata which laws that is being implemented by a law. Most legal jurisdictions have a hierarchical structure. Hence, lower order laws exist to implement the higher order ones in specific areas. And then lastly is the question answering over laws with revisions. Since laws change over time through amendments, legal knowledge services must be able to comprehend these updates. We address this issue by utilizing the legal KG metadata, which includes revisions and amendment properties, such as insertion, alteration, and deletion. This amendment KG has been tested on the Indonesian Act number 11, year 2020 on job creation, which amends over 50 previous laws. So one example is on the Article 13 of the labor law, which has had minor revisions by adding another type of job training institutes. In this case, it's company job training institutes. So next we will discuss on the lessons learned during the development process. The first one, we evaluate our system's performance. We developed 200 question-answer pairs dataset on the Indonesian labor law. We separate the two testing methods, which are KG isolated and end-to-end. We assume clean parameters for the former method and exclude any NLP or retrieval components. For this method, we are able to attain perfect score, which means the knowledge graph has performed as expected. Next, we evaluate on the end-to-end process. So although it only reaches around 60% of pass rate, it is still far better than our baseline BM25 retrieval method. This score is partly attributed to the difficulty in retrieving top 1 result for retrieval questions. The next point in lessons learned is on how we integrate KG with NLP and information retrieval techniques to provide this service. In short, knowledge graph attributes to the semantic, precise, and structured representation, while information retrieval allows for more flexibility in handling various user questions. And then the third point we discover is that law articles may need to rely on other articles to suffice in answering user questions. We try to address this issue by leveraging the use of metadata and context so that user could discover related articles to get the complete picture of the answer itself. Another approach is to use a refined ontology and entity linking so that articles are linked semantically. For example, when answering a question on, let's say, a paid leave, a user may need to first understand what a leave is And then they need to understand what different leaves are there. And finally, they also perhaps want to understand what are the employer's obligations for paid leave. Next, we have the completeness of laws. Laws govern many aspects of citizens' life. And as shown previously, we also have amendments and revisions. These two contributed to the always increasing scale of law data. And accounting this issue would require to keep the scalability and the accuracy aspects in mind. And then finally, we also find the possible future implementation for different law types and jurisdictions. We have explored legal virtual assistant approaches under the Indonesian jurisdictions, and thus, we have to deal with different law types that exist in Indonesia, such as laws and acts, and then government regulations, and lastly, also local regulations. And under different jurisdictions, laws may also apply differently. For example, in the EU, the legal knowledge graph must consider the different languages used by the different EU countries. And then another issue is that the same legal concepts may have different representations and meanings under different jurisdictions. So, in conclusion, our approach has been fruitful for Katapa to make labor law services more accessible. We find that the use of KGs supported the system in capturing the semantic representation of legal knowledge, which has then made it easy for users to interact by creating a virtual assistant on top of it. Our experiments proved that the legal VA using KG improved the baseline retrieval system in offering legal services. And then in the future, we hope that legal virtual assistants will democratize legal services for more people. And lastly, we also want to show our short demo of our system in the form of video. So that is all from us. On behalf of me and my team, I would like to say thank you for your attention.